All right, so Algebra 1, Semester 1, this is our Chapter 3, and we're talking about solving equations. One-step equations, two-step equations, in some cases multi-step equations, which have more than two steps, and we use inverse operations. All right, here we go. So like terms. Like terms are terms with the exact same variable factors. They're like terms. 4x and 5x are like terms because they both have x. Yeah. 4x and 5x because they both have an x. Now notice that 2x squared and 9x squared are also like terms because they both have x squared. Now 4x and 2x squared are not like terms. One has an x and one has an x squared. You've got to have the same exact variable with the same exact exponent to be like terms. The exact same variable with the exact same exponent. Now collecting like terms are putting two terms together. Add them if they're the same sign and subtract them if they're different. Just like integers. You're adding them if they're the same sign, subtracting them if they're different signs. They're on the same, they have the same sign, it's like they're on the same team. You know, you put them together because they're on the same team together. They're on different signs, it's like they're on different teams, and they subtract each other, so you have to subtract. Now, if you notice, there's a problem done for you right here. I did it already. You don't have to copy it down or anything, but it would be good to look at. Notice how I put the 3x and the negative 9x together. And the reason I circle that negative 9x is because you got to make sure you have the negative with that 9. You combine those two together, that's what gives me the negative 6x right there. The negative 2y does not have a like term. So you're just going to take this negative 2y and bring it over here, because there's no like term to put with it. So when we try one, you can put these like terms together. So you keep the negative with the 8. And see what you get. Put it in the box. See if you can figure out what the correct solution or what the correct expression would be in that box. If you put those together. Put 7x plus 3x and put it in there, and then negative 8y and a 5y. See if you have 10x minus 3y. Hopefully that's what you got. If you didn't, fix it. 7 and 3 is 10. And negative 8 and 5 is a negative 3. Now remember, the negative 8 and the 5, we subtracted those because they're on different teams. And there were more negatives than there were positives. There was 8 negatives and there was only 5 positives. So your negatives are going to take control there, and it's going to be a negative 3y. 8 negatives, 5 positives, your answer is going to be negative because there are more negatives. Additive inverses are two numbers that add up to 0. Additive inverses, two numbers that add up to 0. 5 and negative 5. You add 5 plus negative 5, you get 0. You add negative 2.3 and positive 2.3, you're going to get 0. Now that comes in handy. We want to know that when two numbers add up to 0, because that helps us cancel things out and get variables by itself. So if I know that I have a 5, then I need to do a minus 5 because I know that those are going to add up to 0. So you always want to know what the additive inverse is going to be so that you can cancel something out. You cross it out, get rid of it. The additive inverse. multiplicative inverses, numbers that multiply to give you 1. Numbers that multiply together give you a 1. And you could also call them reciprocals. If you multiply them and you get 1 as the solution, that's when you have inverses. 4 and 1/4. You multiply 4 times 1/4, the 4s are going to cancel, you're going to get 1. You could also call them reciprocals. So technically, it might be a good idea over here to put reciprocals. Reciprocals is another way to say it. All right, we're good to go? Let's get to okay, additive inverse is the opposite. I don't know why there's 2 of them there. Is the opposite of a number. The additive inverse is the opposite of a number. So if I was to take a negative in front of this x right here and I distribute it to both terms, this negative is going to give me the opposite of both of those. It's going to give me the opposite of x, which is negative x. It's going to give me the opposite of 7, which is negative 7. Distributing the negative changes both signs, it gives you the opposite of the number. So try this one, distribute this negative, and put your answer in there and what you think it would be if you multiplied this parentheses by a negative. See if you can change all the signs and put down the correct answer there. Hopefully this is what you got. Negative 7a, negative 12b, and positive c. You changed all three signs and took away the parentheses. All right, like terms. So this one's a little bit more complex down here. Everybody got that one? Good. Okay, now look at the example here. This one you don't have to write anything down, but it's good to see how they got from this problem all the way over to this solution. Here's your answer right there. 2 little terms. You had a parentheses, you had 3 terms, you had a negative. First thing they did was they distributed the negative. They made that a negative 8, and they made that a negative 3. Then they put the like terms together. 3 minus 8. There's 3 positives, there's 8 negatives. So they put it together and they got 5 negatives. And then you had your negative 3. So let's see what we get here. If we distribute this negative, it's going to give us a 7x still, a negative 5 still. Those don't change. But now you're going to get a negative 10x. You're going to get a positive 4, because a negative times a negative becomes a positive 4. The 7x and the 10x, the negative 10x, gives you the negative 3x. That's this part right here. That's telling you that these two together gives you this. The negative 5 and the positive 4 gives you a negative 1. So your answer there for that whole thing is just negative 3x minus 1. This is how you get the negative 3x, by combining those two like terms, the 7x and the negative 10. And you get the negative 1 by combining the two numbers, which is a negative 5 and a positive 4. So that is kind of putting a bunch of stuff together. That's putting the additive inverses with the like terms and even integers, combining integers, adding, subtracting integers. All right, moving on. Solving equations. And now here's where the real stuff starts, because this is what we use this for. To solve equations, to get x by itself. So to the addition property of equality, the subtraction property of equality, all it means is that you can add or subtract the same number from both sides of an equation and it will stay equal. So if you add 10 to both sides of an equation, both sides are still equal. If you add 12 to both sides, they're still equal. That's what the addition and subtraction properties are telling us. Make sure you do it to both sides of an equation. You've probably heard the illustration of the balance scale, where if you put the same thing to both sides, the scale stays the same. Just like a teeter totter. If two people of equal weights are on the two sides, it's going to stay equal. You want to make sure that the two sides have the same amount. That's all these two properties are telling us. Just make sure you either add the same thing to both sides or subtract the same thing to both sides. And it's always both sides of the equal sign. You've got to locate where the equal sign is and then put it on both sides of that equal sign. Jacob, did it work? Did you get the worksheet? Oh. Sorry, I thought I gave you one. You the wrong one? Oh, you did? Yeah. Okay. It's on the board. All right, so example 1, here's what they did. The equation said x plus 5 equals negative 7. They used an additive inverse of negative 5 so that the 5s would cancel out. You could actually cross those out to show that they cancel out. They combined these two together because they're the same sign, so they're going to add them up. You should get x equals negative 12. So negative 7 with a negative 5 is going to give you the negative 12. Example 2, you're getting rid of this 8. You might want to circle this negative 8 right there. That's where the y is. You want to get the y by itself. It doesn't matter whether the y is on the left side or the right side. You just want this letter to get isolated. You want an answer that just says y equals. And so if I was to get rid of this 8 right here, now the y is going to be all by itself. So you're going to get y equals 2. When I put the negative 6 together with a positive 8, they're different teams, different signs, so I got to subtract them. 8 minus 6 is 2. There were more positives than there were negatives. There were only 6 negatives. There's 8 positives. So there's got to be, your answer's got to be positive. Everybody okay there? Okay, moving on. I'll get you to the back side. Should be on the back side. Multiplication and division property is almost the exact same. Instead of adding and subtracting to both the same amount to both sides, you can multiply or divide the same amount on both sides. So if I multiply both sides by 2, it's okay. If I divide both sides by 2, it's okay. As long as I do the same thing to both sides. That's the whole key. Do the same to both sides, it will stay equal. Whether you're adding, subtracting, multiplying, or dividing. As long as you do it with both sides of the equal sign, you're fine. Okay, so this first little box here, divide both sides by 3. because it used to, if the equation was 3x equals negative 15, you want to get rid of this 3 because our job is to isolate this variable. We want to get that variable by itself. So we were talking about operations that undo each other. If they're multiplied, then we have to undo that by dividing. So 3 divided by 3, that's the undo operation. That gives you 1. You can cross out those 3's because they would both become 1. You would reduce them to 1. You're just going to get x equals negative 15 divided by a positive 3 gives you that negative 5 right there. And it's a negative answer because the signs are different. Remember when we're dividing, if you've got different signs, your answer is always going to be negative. So since it was a negative divided by a positive, you get a negative answer. It doesn't matter which one's bigger out of those two. That only matters when you're adding and subtracting. Whichever one has more is going to keep the sign. But when you're dividing, if they're different, it's always going to be a negative answer. Look at example 4 here. Your equation is just negative x equals 9. What should we divide on both sides so that we just get x? What's in front of this x right now? A negative. But what else is also there that you don't even see? A 1. There's always like a 1 there. So what we want to do is we want to divide both sides by negative 1. Because now the negative 1s will cancel out and you'll just have an x. And then 9 divided by negative 1 just changes the sign to a negative 9. This one right here, what do you think our first step is? What do you think we got to do first? We want to get rid of that 4. Okay. We need algebra 1, semester 1. We are on the back of the first page. Right there, right now. Oh, you're going to get it. Okay, so the first step we want to do here is divide both sides by 4. You want to get that a by itself. So we want to get rid of that 4. You could now cross those 4's out because they undid each other. 4 multiplied, 4 divided, we're back to where we started. I don't know why I put an x. Same thing. Now, if these two do not divide evenly, just leave it as a fraction. It's just negative 7/4. It's like negative 1 and 1/4, negative 1 and 3/4. You don't have to divide them if they don't. I mean, you could put a decimal. You could put negative 1.75, but you could just leave it as a fraction. First step down here, divide by negative 3. Notice how I divided by the exact same thing that was being multiplied. If they're multiplying by negative 3, I divide by negative 3. I don't want to divide by a positive 3 because that's not going to give me my positive y. It'll end up giving me a negative y. I just want the division and the multiplication to cross each other out. So whatever they're multiplying by is what I have to divide by. And you end up with x equals 14. The positive, because a negative divided by negative, positive. Dividing by the same sign gives you a positive answer. Make sure you can see them, and then we'll move on. All right, I can always come back to these if you need to. More practice. Let's try this one. This one is already pretty much done for you. Now, I showed you two ways that you could solve this one. This is one method. This is two methods. Method number two. Which way do I like? Personally, I like method number two better. But let me show you them both and you can decide yourself. This one has a negative 1/4 times y equals 12. Since they're multiplying by negative 1/4, we divide by negative 1/4. So that way these will cancel out. Now, if you are dividing by a fraction, do you remember how to divide by a fraction? You actually have to change it to multiplication, and then you got to flip the second one around. That's sometimes hard to remember, so we don't always do that, but I would bring down the first one, I would change this division to a times, I would flip this around to become negative 4, multiply together, and I get negative 48. So that's method number one. You could divide by 1/4. That would be right here. Now what I would rather do is I'd rather just get rid of the fraction altogether. I don't like fractions. So I looked for a denominator that I could multiply by that will cross cancel. So since my denominator was a 4, I multiplied both sides by 4, and that crossed out these two 4s and just left me with a negative 1y. And this multiplied and gave me 48. And when I divided by negative 1 to cross out those negatives, now I got y is negative 48. I got the same answer. Two answers were the same. I just would rather get rid of the fraction instead of dividing by a fraction. So you can decide, whenever you see fractions, you can decide, okay, do I want to get rid of the fraction, or do I want to just divide by the fraction? I would suggest the number two, just multiply by a denominator, get rid of it. So if I'm looking at this one right here, what I would do personally is multiply both sides by 2, because that'll cross cancel those 2's right there, and I'll just get 1x, and I'll get negative 16, and you're done on that. So that would be my suggestion, is you see a fraction, find a denominator, multiply it on both sides, get rid of that denominator. That'll make it a lot easier for you. This bottom one, what's the denominator that I'm going to multiply on both sides? The 3. So you're just going to take that 3, multiply it on both sides. These 3's will cancel out. And you'll just get y equals 14 times 3, which is 42. So you get your answer down here, 42. So I think that it's a lot easier. Whenever you see a denominator, just multiply by that denominator so it's gone. That would be my suggestion. It would be a lot easier if you multiply by that denominator. All right, moving on. Everybody okay here? All right, example 1. See if you can solve those. Let's see how you did on at least the first one. You should have added the 7 to both sides and then got 19. What I would rather see it though is I would rather see your 7 right underneath and then canceling out, and you get a is 19. So that's the way I would like to see it. I think it's a little bit easier to follow that way. Number 2 example. Hopefully you got 6. And you can always go back and double check your answer. I mean, I could take this 19 and plug it in here. Is 19 minus 7 12? Yeah, it checks off. It does work. 6. Could I put a 6 right here? What's 3 times 6? 18. It does check. See, you can always put your answer back in your head and just do a quick mental math to see if you got it right. And then the last one, you should hopefully have multiplied both sides by 3 to cross that denominator out. And then 3 times 18 is 54. So check that, see if you got 54 for that one. Hopefully those are pretty easy for you. One last slide on the first page. On here. Okay, now this has multi-steps. Multi-step equations means you can do more than 2 steps to solve it. I actually did the whole equation for you on this first one. I just wanted you to write down what the steps were. You're going to try to get the x by itself. Okay, that's always our goal. First, you're subtracting 4. Next, you're dividing by 3. So we did 2 steps. Step 1 is right here. Step 2 is right there. Subtract 4 from both sides is step 1. Divide by 3 on both sides was step 2. Here, these 3's would cancel out. You'd end up with x equals 3. And again, you could always put that number back in and see if it works. 3 times 3, if I put a 3 in there, that's 9, plus 4 more is 13. It would check if you put a 3 in there. So you can always make sure you got the right answer on these if you need to. So it's a 2-step process. Get rid of any addition or subtraction first. Get rid of any multiplication or division second. So what do you think I should put underneath these 2 blanks? You're going to have -6. There's your -6. You're going to subtract 6 to both sides because you want to get 6 out of there first. So you could put that these 6's just cross-canceled right there. What do you get when you combine your 16 with your -6? You get a 10, a positive 10. Good. What should I now do on both sides so that I can get x by itself? What should go under these 2 blanks? A 5 or a -5? -5. Yeah, you want to, since they're multiplying by -5, you want to divide by -5. And that's how you got the -2. So I subtracted 6 on both sides, I divided by -5, and I got x by itself. Those are my 2 steps. I'll leave this one for you to try. I gave you the steps so you know exactly what to do to solve this one. So give it a try and see if you can get so you get an x equals a 5 for that one. You subtracted 6 and divided by 9. Good to go? Alright, moving on. We're almost done here. Last couple. Most of these are filled in for you. Now, multi-step problems means you could have more than 2. In this case, we're going to put our like terms together, and then we're going to divide by 8, so the 8's will cancel out. And I left it as a fraction, 15 over 8. So that was just putting 2 like terms together first, and then dividing both sides by 8. If I put these 2 like terms together, you're going to get a 5x, and then if you divide both sides by 5, (20) divided by 5 is going to give you a 4. So you might have to put a like term together before you solve it. So those are just like terms, 9x and -4x. You had 9 x's, so you had 9 little letter x's in your hand, and you took 4 of them away, so now you only have 5 left. 5 x's, you divide by 5, these will cancel out, you'll get x equals 4. Now, I think I gave you the steps on the paper for this one. Yeah, I did. So, distribute by 2 first. So what you should probably do on this is draw in the rainbow, so you know we're distributing. So that's the rainbow there. That's what you get after the rainbow. You get 4y plus 6. 2 times 2 is 4. 2 times 3 is 6. So when you distribute, you get this right here. Then it's a multi-step problem where you're just going to subtract your 6, so they'll cancel out. And these two together give you 8. And then divide by 4, so those cancel out. 4 divided by 4 comes out to 1. And then 8 divided by 4 is 2. So you get your answer of 2. If you're already cut up, see if you can fill in these boxes. See if you can fill in what number goes in each box. You're already cut up. What do you think will go in this first box? What's 4 times 3x? 4 times 3x. 12x. Should go in there. I don't know why there's 2 of them. Be at 12x. And then 40 should just come straight down. 40. What can we put together? 12x, those are my like terms. Positive 12x and another positive 12x. So how many x's do I have now? 12 plus 12 is 24 x's. So that's going to go next. 24 x's. So 24x minus 8 is 40. What am I going to do to both sides? We want to add 8 to both sides. We want to add 8 to both sides. That will cancel out these 2 8s. 2 8s will cancel out. So you're still going to have your 24x. That's not going to change. And 40 plus 8 is going to give you 48. That's not going to change either. Well, you add the 40 plus the 8. We're going to divide both sides by the 24. If you want to get x by itself. And get x equals 2. 24s will cancel out. 24 divided by 24 is 1, and then that's 1x, which is just x. 48 divided by 24 is just 2. All right. That one you don't have. Go to this one. That one is our next one, I think. Yes. Okay, keywords for addition. These are just in word problems. If you see the word sum, that means you're adding. So you're just going to write these numbers in the boxes, or these words. If you see total, if it says what's the total of all your grocery items, your total means you added them all up. So an addition word is total. Sum is an addition word. Total is an addition word. More than means addition. 10 more than 20 or whatever, you're adding 10 to 20, more than. The added to is a addition word. Added to and increased by. And the word quantity also means addition. Usually when you're finding the quantity, you're adding them up. Those are just key addition words that you would see in any, you see those words, it means you're adding something. Subtraction words. Main one is the word difference. What's the difference between two numbers? It means you got to subtract them. So the main key word for subtraction is the word difference. But there are some others. Less than means you're taking it away from that. So any 5 less than x means x minus 5. You got to do minus. Less than really means taken away from, though. You're taking it away from the number. Decreased by is a subtraction word. 8 decreased by 5 means 8 minus 5. Subtracted from and fewer than would also be subtraction word. 2 subtracted from 8 means 8 minus 2. Fewer than 6, fewer than 8, so you do 8 minus 6. Multiplication word. Multiply, product. Those are two main ones. Product is the one you see the most, probably. Find the product of two numbers. Means you're multiplying two numbers. So multiply is a key word, and product is a key word. The word of. That doesn't sound like multiplication, but if it says find 10% of 20, it means you're doing 10% times 20. It means the of is the multiplication word. And the word times and the word twice or double means you're timesing it by 2. So times, twice and double, both of them mean you're multiplying it by 2. If you see the word twice, you're going to times something by 2. If you see the word double something, you're timesing it by 2. And of course, division is very key. Quotient divided by and half. Quotient means division, divided by means division, and half means you're dividing by 2. I give you those because in section 3-4, you're writing out little expressions, using these words to write down some of the expressions that you need. And in the next couple of slides, there's just a few blanks, so we'll just fill in a few blanks and we'll be done. Okay, so write as an algebraic expression. The sum, what does sum mean? What column was sum in? Addition, right? So the sum of 5 and a number means that you want to have 5 plus x or you want to have x plus 5 because you're summing them, you're adding them together. X is going to be the number and 5 is in there. So 5 plus x or x plus 5. Five times the quantity, 3 less than a number. Okay, so 5 times means we're going to multiply. Quantity means we're going to need some addition in there. 3 less than a number means we're going to have subtraction in there. Quantity usually means addition. But let's see if we can. Less than means taken away from. Taken away from. Okay, so the actual answer is 5 parentheses x minus 3. In this case, quantity just meant parentheses. But quantity might mean add or quantity might just mean parentheses. In this case, we have less than 3 less than a number. I can tell you right now, a lot of students like to put 3 minus the number, x. That's not 3 less than a number. That's x less than 3. That's x taken away from 3. We want 3 taken away from a number. We want 3 to take away from the actual number, which was x. So you've got to put that 3 in the back. So whenever you see less than a number means the number x is going to go in the back. So 3 less than a number means x minus 3. Negative 3 times the quantity 4 less than 2 times the number. So negative 3, quantity is our parentheses. 4 less than So guess where the 4 is going to go here? 4 less than. Where's the 4 going to go? The first one or the second one? Got to be in the second one right there. 4 less than means you're taking it away from. Taking 4 away from 2 times the number. So the 2x should go there. 2 times the number goes here. Take 4 away from it because it's 4 less than that. So negative 3 and then 2x minus 4. 14 less than. So the 14 is going to need to go at the back. The product of 3 and a number. So you're going to just have the 3x minus 14. 14 less than the product of 3 and a number. So you're taking 14 away from 3 times the number. So 3x minus 14. Just 2 left here. 2 quick ones. Jason's weekly salary is 35 less than twice David's weekly salary. D is David's salary in dollars. Write an expression using D for Jason's weekly salary. Okay, well, David's weekly salary we just said was D. Okay, so letter D is David's weekly salary. Jason's is 35 less than twice that. How would I write that? That's what we want to put in this box. 35 less than. Where's the 35 going to go? In the front or the back? 35 less than. It's got to go in the back. Twice David's salary is going to be twice D. So you're looking at 2D minus 35. So you're 35 less than twice the salary. 35 has to go in the back. Twice the salary. This year, Todd sold 5 fewer houses than twice as many as he sold last year. N is the number he sold last year. Write an expression for the number he sold this year. Okay, this year, 5 fewer than twice as many. What do you think? 5 fewer than. It's like we had 35 fewer than twice as many. This one's 5 fewer than twice as many. So I believe we're going to have the same kind of thing here. You're going to get 5 fewer than is going to be a minus 5, twice as many, twice n. So 5 less than twice as much. So you're going to take twice as much, but then you're going to take 5 away from that because he didn't quite do twice as much. He did 5 less than that. Let's say he sold 20. So you'd have 20 times 2 would be 40, minus 5, he would have sold 35 this year. That's 5 less than what twice would be. And then the last page. The number of girls in the band is 6 more than twice the number of boys. There are 88 girls in the band. How many boys are in the band? Okay, so let B equal the number of boys in the band because that's what we want to know. There are 6 more than twice for the girls. So the girls has 6 more than twice that much. So 2B's plus 6. So there's way more girls in the band. There's double it plus 6 more girls than there are boys. So the equation that we're going to set up is that this amount of girls, 2B plus 6 girls, is going to equal 88 because they told us there's 88 girls in the band. What am I going to do to start to solve this? What would be my first step here? How do I get rid of that 6? We're going to do a minus 6 to both sides because you want to get rid of the 6 first. Those cancel out. That's going to leave you with 2 B's left, and then 88 minus 6 is 82. Divide both sides by 2 so that these 2's cancel out. And 82 divided by 2 is 41. So there's 41 boys, there's 88 girls in the band. Kara has driven 75 miles. She averages 55 miles per hour. How many more hours must Kara drive to travel a total of 350 miles? Let H be the number of additional hours she needs. We always want to let our variable be what we're looking for. How many more hours must she drive to get 350 miles? She's driven 75. She's going 55 every hour. So every hour she does another 55, another 55, another 55. She wants to get up to 350 miles. So let's let 55 times h be the additional miles she needs to travel. 55 miles times however many hours she decides to go. The equation is the additional miles plus the miles she's already done. The additional miles plus the miles she's already done. It's got to add up to 350. If you look at the little chart there, I was kind of showing you what it meant here. 350 is the total amount she needs to go. 75 is what she's already done. But she still needs to go this much distance. And she's going 55 miles per hour to get to all the way to the end here. So this one plus this one equals the total of 350. So that's how we got our equation over there. Is the miles she's done plus the miles she's going to go is going to equal 350. So if you solve it, subtract 75, those will cancel out. Divide by 55, those will cancel out. 5 extra miles is what she would need to do. 5 extra miles. Alright, it is 9 o'clock, which means that we have an hour left.